Hi, my name is Sean Mars and I'm an applications engineer with Awkward Systems, and today we're going to talk about energy norm error plots in SOLIDWORKS Simulation. So the energy norm error plot is a type of stress plot that tells you where you have error in your stress values and how much error there is. So what we can see here is we have a lot of red. That basically is saying anything above 3% error, which is what I've set as my upper level. And then anything that's in this blue and green is where I have less error, more accurate results, and what we'd expect is that's where I have the mesh refinement here. So this is really a tool to kind of use with your normal stress plots to help you determine where you'd want to be refining mesh and how much mesh refinement you need to do. So really the way that this plot works is based off of your nodal versus elemental stress values that you can have displayed in these plots. So a couple things before we talk about how SOLIDWORKS creates this. First off, to create this plot, you just need to start. I can make a new one here. You can start any stress plot here, or you can go to any existing one, and you're just going to choose this energy norm error component option. So that's the only thing that makes it this energy norm error option here is choosing that. All right, another quick thing here. If I just go to any of my stress values here, I just want to show that there's also these options between node values and element values. So what do we want it to show? And our standard stress plots are going to show nodal values. So that's what we are used to seeing. Most of us are used to seeing with these blends of colors on our color plot here. And we can see what's really happening there if I show the mesh is that the color is changing across the elements. So this is in contrast to if we choose that elemental option. And then this one, you can see that full elements are one color, so you can actually see the mesh without it actually turning on that mesh display here. And so you can see that each one of these elements basically has one value in our stress plot as opposed to multiple ones going across. So to explain why this is happening, we should go over to our help file here. So I'll just look up our energy norm error here. And we want to look at our node values versus element values. And basically what we're looking at is if we're looking at any of our mesh elements, we have 2 points of interest. So we have our element nodes, these little red dots, where each of our mesh elements are going to be meeting, the vertices essentially, and our Gauss points. So those are located within the mesh elements. And the Gauss points are where SOLIDWORKS is actually doing the calculation. So when you're asking for a stress plot, it actually has calculated the stress at Gauss points within each of the elements. So if we use our standard high quality second order elements here, then we'll have 4 Gauss points. So it'll look pretty much like this, plus there'll be one in the like near the other node that we can't see, so into the paper. And what it's going to do is when we're asking for either nodal or elemental, it's doing some sort of average. So once again, nodal is what we're kind of used to seeing with that color blend, and what it's doing is taking the Gauss points near the nodes and averaging them. So each node is going to have its own value. This is going to be taking Gauss points from across multiple elements. The elemental option is going to be more of like an internal average. It's just going to average the values of the Gauss points within each element. So really there's no right or wrong answer of which one is more accurate. It's just different ways of displaying the results. But there is a discrepancy between our elemental value and our nodal value. They are different. And so what our energy norm error plot is doing is it's looking at this discrepancy, and that's how it's calculating what the error in our stress results is. So basically, as your mesh elements get smaller, your nodes and your Gauss points get closer together, and your elemental and your nodal values converge to the same value there. So the smaller your mesh elements, the less error you have in your stress results. So how do you really use this? Well, basically with something like this, I would kind of start with just like a relatively rough mesh here, and then I could use my stress value, my stress plot, to kind of look at where is my highest level of stress. I also might be looking in at critical areas of my design, and then I compare that with my error my error plot here. And we can see in areas that I'm interested in, my high stress areas around here, we have high error as well. So by adding mesh control to those areas, I can not only bring down the error in those areas, so I can see I have much lower error. That's actually less than 1%, very, very small. That's to the -3 there. I have very little error there, and that's also going to give me more accurate stress results in those locations as well. And so this is all about balancing your mesh size and your accuracy of your results versus how much time it takes for these calculations to be done. So obviously I could bring down my mesh size on the entire model, but that would take a very long time to solve. So I'm really just going to do it in the areas I'm interested in. And I basically just went until my stress values were going over my yield for this material. Because at that point, I don't really care what's happening past yield. I'm just interested in the fact that I do have yield in these areas here. And so now I need to maybe go back and work on my design, or change my setup, my simulation, or just run other studies. Okay. So today we went over not only the energy norm error plots, but also those elemental versus nodal displays and kind of what they mean. So thank you very much for watching. Don't forget, we have all sorts of Facebook, YouTube, all that kind of stuff. So go ahead and check us out elsewhere if you liked this video and you're looking for some more.